Okay, for any projectile um, that's launched from a height of any height, and the projectile is launched horizontally, you can treat the questions all very similarly. And that's why when I did this, or I prepared this question for you, I didn't use any numbers because when you identify the question that you're trying to solve as a projectile being launched from a height, could be 100 meters, could be 50, whatever, and you recognize that it's being launched at a horizontal, perfectly horizontally, with velocity v, then all of the questions are the same. And what's going to happen is the projectile does this and makes half a parabola. So one half that we're interested in is here, and the other half is over here. And specifically what we're looking for in this question is the range. So the range is our horizontal displacement. So in order to solve this question, we treat this as two problems. We look at what's happening in the x direction and what's happening in the y direction. So in the x direction, what do we know? Well, we know that projectiles do not accelerate in this direction. So the acceleration is 0. And we know the initial velocity, which is also the final velocity, because there is no acceleration, and that's equal to v. Now again, you can replace this v with any value you want. So if it could say 30 meters per second, 150 kilometers per hour, which you're going to convert to meters per second, whatever. And then what we're looking for ideally, or at the end, is delta dx. So right now we don't know enough information to solve for delta dx. So what we do is we look in the y direction. And in the y direction, we know a little bit more. We know, for instance, that the vertical velocity initially is 0 because it's not moving initially with any velocity in the downward direction. So that's VIY. We know the acceleration is due to gravity, so it's negative 9.8 meters per second squared up. And in fact, we'll keep not using any numbers. We'll make this just we'll make it g. So this value is now in here. So that's in the y direction. And we know that the vertical displacement is equal to whatever value this would be, it would be a negative. So let's make that negative h, and that would be up. Okay, and so we don't have anything common between these two guys right now. So what we need to realize is that the time it takes for the object to drop is the same as the time it takes the object to get from here to here. So what the two directions share is the change in time. So once we know that, then we find a kinematic expression in the y direction that involves all of these elements in it. And the one that 99% of the time crops up is this one here. So this term goes to 0. And then this here is negative h equals half gt squared. And then we're solving for t. We're going to replace it in here. And so if we do our algebra here, oops, made a mistake. That should be square root square root divided by g. So that's equal to t. Now, when you take the square root of any value, you automatically get two values. So what does that mean in terms of the question here? Well, the positive is the time it takes the projectile to go from here to here. And the negative, because this is a parabola, there's also another intersection point on the other side. So that's the time it would take kind of for the projectile to go either that way or to come up from that position. So we ignore the negative sign and we only take the positive value. Also, if you look inside the root symbol, there's a negative in here. You're probably worried that the negative, taking a square root of the negative will get us an imaginary number. But remember, g is negative. We just didn't put it in. So when we put our values in, we leave h as a positive value, and then our g value we replace completely with negative 9.8. So those two negatives would cancel and give us a positive. Okay, so now let's figure out our relationship for the x direction. And this one is simply the same relationship actually. But in this case, a is equal to 0, so this term goes away. And so we're just writing this term right here. So that equals vi delta t. And we know that v is equal to, vi is equal to v. And then delta t is equal to this. So we can replace this with what's under the square root here, negative 2h over g. And that is our answer. So again, this may seem intimidating, but just realize that you will be getting a question that looks very similar to this with a value here and a value here. And what you do is you just replace the value v here in meters per second, because it has to have the same units as this, as the acceleration due to gravity, and as the height. And the height, you just replace the numbers. So if it says 10 meters up, then you would put 10. And then for g, you would have to replace it with negative 9.8. And then once you crunch all those numbers in your calculator, you'll get the range. So therefore, the range is v times the square root of negative 2h over g, and then you have some kind of units here, probably in meters, and in this case our direction is to the right. There you are.